Welcome back, Math Marbles. This is lesson 77. We're going to find the area and perimeter of figures on a coordinate grid. So this is the thing I'm going to model for you. One, I'm going to plot coordinate points on the grid to create the polygon. Then I'm going to find the length of any dimension using horizontal and vertical lines. And then I'm going to use all those dimensions to find the area or perimeter of the rectangular polygon. A figure has vertices at these 4 points: -2, 2, -2, 6, 6, 6, and 6, 2. Which term best describes the figure? If we were to graph it, what shape could it make? So one strategy I automatically know some students will do is to make a sketch of the graph. That would be one simple way to sketch out what was happening. Another thing I want you to watch and look for is, notice how we have the same points repeated. Like we have 2 points where x is -2. I have 2 points where the x is 6. And then I also have, it looks like points that are at, again, here's another where y equals 6. And our final one, we can see where the other y is equal to 2. What does that mean? So right now, these are all numbers. I know that we have points on the same lines, on the same points on x and y, but what does that even mean? Let's see what happens when we draw it out. I'm going to quickly just sketch. Here's a line. My first point is at -2, 2. So here's -2. I'm just going to make up a point for 2. My next one is at -2, 6. So take a look. These were the 2 points. These two over here were both at -2, and they're right on top of each other. So that's important. Now, let's look at the next ones. The next points are at 6. So I'm going to make a line here for 6. The third one is at 6, 6. And the fourth one is at 6, 2. So just looking at those points, when I have 2 points on the same x, they make a straight line going down, a nice vertical line. So we have 2 vertical lines. And then I also have 2 points that are at +2. And those 2 points make a line. And I have 2 points at 6 when y equals 6. So here we go. With my quick sketch, we have a rectangle. Hit pause and jot this down. When you get a question like this, making a very quick sketch can be very, very helpful. Using a coordinate grid, I'm going to show you why the area formulas for a rectangle and a parallelogram are exactly the same. For example, for a rectangle, we would use these 2 dimensions. Pretty much the bottom part, which sometimes we call length width, but we could also just say base height. So why is it for a parallelogram, why can we use the same formula, base times height? I'm going to show you why using this coordinate grid. I see my shape. I'm going to use decomposition. And I want you to imagine me cutting this parallelogram right down this line. And imagine me taking that piece and putting it over here to make a rectangle. First question you probably ask me is, well, Sarah, are these 2 even the same size? So let's check. The bottom dimension is 1, 2, 3, 4. 1, 2, 3, 4. So these parts are the same. And they both have the same height of 3. So they are exactly the same size. And because they are the same size, I can now find the area using the same dimensions, our base times our height. Even when I cut them, they are still the same. So think about it here. Take a look. Here's our base. Our base would have 5. That's our length. And our height would just be 3. If we were to go back to the original shape, we would still have a base of 1, 2, 3, 4, 5, and a height of 3. So this is why the formula for area of a parallelogram is exactly the same as area of a rectangle. You only need those 2 dimensions. So with that, let's calculate our area. So area of a parallelogram is base times height, or 5 times 3. The area for this parallelogram is 15 square units. So once again, using a visual and using decomposition, we're able to see an area of a figure. Hit pause and jot this down. Let's try one more. We have another quadrilateral here. It looks like a diamond. However, notice I don't have a base I can add up because it doesn't sit on any of these vertical or horizontal lines. And I can't count diagonally. That's not the same as 3 here. Not exactly the same. So we're going to use decomposition again. And what figures can we make from here? We can cut this and make 2 triangles. Here we go. Now we have 2 triangles that are exactly the same. So we're going to write down our formula for area of a triangle. So my formula is going to be for this entire piece 2 times the area of the triangle. And our formula is 1/2 times the base times the height. Alright, so our base, 1, 2, 3, 4, 5, 6, and our height is 3. So 2 times 1/2, 6 times 3. Alright, let's multiply those all out together. 2 times 1/2 times 18. And I can already see it's going to be 2 times 9, which is also going to give us as a final answer 18. So our final answer is 18 square units. So once again, big takeaway: when we have a figure that we're unsure about the area, you can use your visual, you can decompose it into triangles and rectangles. And it's even easier when we have a coordinate grid because we have the vertical and horizontal lines. That's it for today's lesson, Math Marvels. I will see you again in the next lesson. Take care.